Greetings, everybody. This is Eric Andelin, Senior Workflow Advisor with SimActive, and you're joining us for the webinar, Do Larger Format Sensors Increase Mapping Productivity? And I'd like to introduce my guest, Dr. Mohsen Miri, Director of Global Strategic Partnerships with Phase 1, as you can see from all the beautiful equipment in the background. Mohsen, say hi.
Hey, greetings from our Denver office in Broomfield, and I'm super happy to join this webinar and talking about the sensors and productivity and solving problems.
Give us a little bit about yourself and your background in Phase 1.
All right, so I can say I am around 25 years in this industry, so in geospatial industry, started from GIS and going to the photogrammetry, image processing, laser scanning, somehow having hands on any part of imagery and reality capturing instruments, and also on the workflow. So with the background of product management at some stages in my career, steps in photogrammetry portfolio, and also being the head of products for Phase 1 manned systems. And right now I am the responsible person to bridge somehow these roles, product management, R&D, sales, and towards the customer to understand what we can do best, efficient together with our partners like SimActive.
Very exciting, very exciting. So today's topics we're going to cover are determining your project requirements, choosing the right imaging sensor, understanding the impact of sensor size on processing, and simplifying your processing workflow. And before we even get into that, I want to do a special shout out to our friends at ADS. They have provided the demo data that I will show later on. They are using the Phase 1 280 camera and having great success with it. So we appreciate them sharing that data with us. And with that, we'll move forward. So I'm a fan of Phase 1. I always have been. They're great cameras. I've been to your guys' offices in Colorado. Coming from the aerial mapping world, which is where I came from with, old Leica cameras and things like that. And then having to drop down into the drone world where they're using cameras, at least in the beginning, that were just off the shelf, cameras that really had no calibration or any quality to them. It's really nice to come back into the world and see Phase 1 not only has cameras for large format aircraft, they put them in satellites, they put them in drones. So it's a complete range of systems or sensors that you guys provide. So with that in mind, let's talk a little bit about determining project requirements. A lot of people that come to us at SimActive, and I'm sure it's the same with you guys, they all don't do the same thing. Some people are doing corridor mapping, some people are doing wide area mapping, all kinds of different things. Some people are mapping cell towers. That's a different world, but they do it. And now we see things like 3D modeling and city modeling. So talk a little bit about how you guys operate within that big space.
Great question. As you're seeing right now here, these are the Phase 1 systems and products, so simple presented here, but you will see Phase 1 cameras inside the partners, instruments, measurement instruments like laser scanning, like thermal mapping, etc., to bringing the pixels, or let's say the RGB and near infrared imagery parts to that hybrid sensors, right? It's a big business. We are talking about capturing the reality in many ways and also for many applications. It starts from, let's say, from the ground. If you have a handheld camera, so if it is a Phase 1 camera, you can do reality capture in close range, and you can go to the platform, payloads, like UAVs. We have P5, which can go really to sub-centimeter accuracy. We have P3, which brings you the possibility to capture images and go into resolution to sub-millimeter. And then you will go up in the air with aerial photogrammetry and using, let's say, PAS 150, for example, as a system, or PAS 280, and a larger format being flexible for small to medium and sometimes also the large projects. And then it goes to other products like you're seeing in the background, PAS 880, doing 3D modeling for smart city applications. And there is another product that we have named PAS Pana. I name it a country scanner, right?
Yeah.
It has a large swath of 48,000 pixels. It can scan areas in large countries like US, let's say like Australia. You have the possibility to capture everything you need in a most productive way.
Yeah, and I really like that, and I think that's why we fit together when folks use SimActive. Is that not only are you doing work all the way down to the sub-centimeter level with drones, but you're also going into, like you said, countrywide mapping, which is where we came from. So it's a good fit. So GSD, like you said, and sub-centimeter stuff for drones, that makes sense. And then as you start to get higher into medium format and large format, that clearly we're farther away from the ground, so the GSD can go up, but that's fine because the quality in the sensor helps clear out things like image motion, things like that. So you're still getting a high quality image. Can you talk a little bit about what's special about your sensors and the optics that you guys have built into the systems?
Yes. So what you're seeing actually here on the table, I brought two of the single cameras, the IXM series, with different objectives. So one is 90 millimeter, the other is 180 millimeter, right? Here we are talking about focal length, right? That means we are talking about scale. We are talking about ground sampling distance, about resolution. This is a whole journey, what happens through the lens toward the sensor, right? And with phase one, we have the flexibility to offer different products to cover this spectrum of geometry, scale, resolution, GSD, etc. It's very dependent on your specification, your requirements, on what you would like to capture, right? For example, if you are interested to cover a large area using PAS Pana, and you are interested to doing project like NAPE, agriculture, you might not need to go to the sub-centimeter resolution. You would like to have larger format, you would like to fly higher, you would like to cover more with less images, right? And this is something, it comes always on the table if you are discussing with the customer. Do you really, really, really need the highest GSD, right? Because it comes to the processing, it comes to the demands, and we are now in an era of AI, right? Geospatial AI-driven features, right? It depends on what you're seeking for. Are you going to extract single trees or buildings or solar panels, or are you going to extract cracks on the pavements or roads?
Yeah, you're right. That does bring in a whole new avenue down the road for folks as AI gets better. So,
and maybe just adding something that on one of your questions about the speed, about motion, about blur, about many things that comes to the game if you're acquiring data, right? The strength at phase one is we are using very strong and professional and innovative shutters. We have also different to this IXM that I have on the table, another technology which is called GS120, which is a global shutter technology. This helps you if you fly over areas with higher speed, right? Sometimes you would like to do, I don't know, with a drone payloads that you can carry GS120, or you can carry, let's say, the P5, you would like to fly faster. And we have on the website a tool that you can play around this. This is my focal length, this is my GSD I'm expecting, this is the speed that I can fly, and you will see in which range you are safe, that you don't have any blur or any motion on your pixels.
Takes me back to the old days when I was sitting in the back of a plane, working an old RC-20. We didn't have that benefit, so it's good to see that people do now. So you also then, when someone comes to you and they're looking for a sensor, you can help guide them into which, as you said, do you really need this type of accuracy? Do you really need this type of GSD? What overall are you doing in your line of business? And then we'll help find the sensor that fits best for that solution. Okay.
Correct. And also what is, we have project specification, we have sensor specification, we have workflow specification, and we have use case specification, right?
Yeah.
So if I have here the 150, which is small, which is super light, you can carry it really with one hand. And this one at 280, it is also super compact. Mm-hmm. You can carry it also immediately integrated inside the aircraft. Some of them, we have customers that they have one pilot as an operator, small aircraft. Mm-hmm. The close or the neighbor seat of the pilot is a camera. That means you can fly over. The pilot is doing the operation, and the operator, the camera operator, if you have enough, let's say, connection, and you can use satellite internet, the operator is doing home office while you are capturing. They can just observe how the operation is happening, right? This is very important for us. Mm-hmm. That before you land, you are sure that you capture everything in the air, and we can do it in online quality control. Hey, you flew over, but something happened. I don't know. In this image, there was a cloud, or one image is missing. Can you refly that line coming back before landing? It's very important that the QC happens in 3 steps. One is in the air. This is because the cost being on the air, right, is huge. Taking off and landing, and all these organizations, the permissions you need from the aviation stations, right? You are safe. Hey, I covered the project. I am safe. I can now land. I'm super happy. Project is done. Then you land and go into the next step. The whole step is very simplified in the phase 1 ecosystem. So you plan it in IXPlan, like, I don't know, corridor mapping, aerial mapping, etc. You're safe. You feed this information to the next software, which is called IXFlight Pro. This IXFlight Pro software will help you to operate, and also giving you a QC in the air. You're safe. It's everything fantastic, right? And then if you land, you can do the QC in IX process. This is a classical workflow that you can utilize in your workflow, color balancing, adjustment, etc. Another method is, if you have a typical types of project that you're sure this is my template, right? This is my configuration. If I fly over this area, you can just integrate the IIQs directly to SimActive.
Yep.
There is no more steps in between needed. You're safe to just be productive, nothing in between, and going in the next steps.
Yeah, very good. So we're kind of there. We're talking about choosing the right imaging sensor. We already talked about electric versus mechanical shutter, or maybe you go into a little bit more detail about that.
Yes, it depends on the speed, right? If you can fly low and slow, right, with let's say mechanical shutters, you can really utilize 280. We have customers are doing that with 280 or 150. Mm-hmm. With 150, you have more flexibility on the lenses that you're seeing, for example, here as components. Mm-hmm. You can reach the 1 centimeter GSD if you can manage it. Yep. And even without the global shutter technology, we have a customer who reached 1 centimeter GSD with 280, and they are using that for applications like detection of the somehow diseases in trees, right? Because if you are interested to have RGB, it's fine. These two cameras are inside. If you're interested to have a 4-band system, right, you can have the nadir also, the near infrared together with the nadir cameras, and you have 4-band, and you can do the vegetation in the indices and analysis on the vegetation, and really managing that in 1 centimeter. But if you would like to fly faster, this is the global shutter technology. You can integrate it in your workflow in any way based on the GS120 technology.
Okay. So, and then I assume flying height affects speed, because if you're lower, you're covering more ground relative. I don't know. Explain a little bit of about that to me. If you're flying a drone versus flying an aircraft, which one's most likely going faster, covering more ground? Probably the drone.
Yes, definitely would be the drone.
Yep. Okay.
And our P5, I don't have it on the table. It is smaller than this. It's quite the size of the body is half of this, and much lighter. It's 700 gram, very light.
Okay.
That would be the drone.
Okay.
We have data sets that shows, for example, for applications like railway monitoring and inspection, and you fly fast with P5, for example, with platforms like Quantum System Trinity Pro, and some objects coming towards you. That object is obviously the train, hopefully. And you will see, even on the train, that means double speed somehow, you can see there is no blur on the train. Fantastic. So that's somehow a proof of concept that this technology is delivering the pixel accuracy and geometry that we are expecting.
Again, a little bit about why the optics that you guys include in your systems or sensors in general outperform off the shelf. We're not talking about large format aircraft at the moment. We're talking about drones, but a little bit of the difference.
Perfect. To ensure that the whole pixel is in the right place in the workflow towards the orthophoto generation or any other products, we have calibration. That's the topic that it's very important for us, that we deliver metric cameras. Metric generation of cameras is first, we have cameras which is stable, right, and robust, and the lenses and focal lengths, everything is fixed for this data capturing. The next step of providing metric cameras is calculating the calibration. The uniqueness of our, let's say, cameras compared to the others, I would say, is specifically the sensor has, if I talk about the drone that you are now interested in, like the P5, we have calibrated sensors like 1 to 5th of the pixel size, right? This shows how stable the pixel is inside the sensor, so on the back side. And the next is the calibration of the lenses. So somehow the lab calibration and also the flight calibration, those are two different topics. But the homogeneous lens distortion, right, is very important. You have different focal lenses, they will have different distortions. Some of them are larger, some of them are less, depends on the focal lens. But if you have homogeneous distortion, you can calculate it in the internal camera calibration. That means if the sensor is calibrated, so I have hopefully one of them here. So it shows here, yes, we're calibrated, for example, and we are set, right? It is in lab calibration. Then it goes to the, let's say, aerial calibration, self-calibration. This is somehow a proof of not only your camera is calibrated, but also your system is calibrated. Because this system is a combination of different sensors, right? It is navigation, it is GPS, IMU inside, and this is one camera. If we go to the multi-camera systems, like let's say 280, we need to ensure that this whole system is stable inside, and it happens in the flight calibration. The other one in the background is the PAS 880. It has two of these 150, which is a 280, and also the oblique. The whole system should be calibrated in the workflow, and this is so-called the flight calibration.
Yeah, and to the viewers, the more solid that sensor is, the more that it's calibrated, the fact that at temperature it stays the same, you don't lose any, you don't have any variation in it, and when you fly it again, you don't have any variation in it. That makes it much easier for the software on our end to process that data out. So I would say that's a big difference. We can process anything as long as it's an image, but the quality that comes from anything it varies greatly. So what I really like to tell people is that, when phase one imagery comes in for us to work on or us to review, we like it because we know it's going to be good stuff versus, someone, a P5 versus, just what's on a DJI drone. There's a difference, and you can tell. And then, like you said, in the higher altitude stuff, when you get into multiple sensors, they really have to be tied together and maintain that conformity, because the whole output relies on that, and it's very important. And as you said, you go from one sensor to four sensors to two sensors to four sensors. It starts to make a big difference. So I mean, you talked a little bit about calibration, and I've been to your lab calibration site the last time I was around, and very cool. It's outstanding. And then again, you have field calibration, where, like you said, you've got an IMU attached to it, you've got airborne GPS, you need lever arm adjustments, you need all these things to find the center of where that photo is being captured. And that is done in the field, and it may be done over a specific site. So some people, like ADS, for example, they might have their own, what you call a bore site, with surveyed in control points. They're known. They fly over it every once in a while just to check everything. Everything should be the same. If it is, you're good to go, and you can continue mapping. And when a camera is not metric, that is very hard to do. When it is metric, you should expect that it'll be in the right frame. Everything will be good, unless for some reason something got bumped or this or that. But that's rarely the case. Anyhow.
And you see that in the final products, right?
Yes.
If what you're delivering is also photo point clouds and meshes, right? Mm-hmm. And you will see that if you compare phase one cameras, right? We had previous to this the session and meeting comparing P5 with other providers outside. Uh-huh. It came that the autophotos was somehow in the same level. Let's talking about phase one higher, yeah, but acceptable, both acceptable. Mm-hmm. But if you show the DEM, right, DEM point clouds, you will see the noise and the quality of the geometry in the background of that photo.
Yes.
What created that autophoto? And this is where you go, object extraction, feature extraction, I don't know, on rail monitoring, etc. This is where the geometry will show how the quality of the cameras is to produce that end products, right, in SimActive.
Yep. Yeah, any blur in an image or a pixel creates noise. And it's funny, we're talking about noise and point clouds, but yes, we have a lot of customers that make point clouds from imagery. They are very good. They're very useful. They're good for city modeling and things like that. But like you said, if it's a noisy point cloud, you have the same editing issues you have with LiDAR. So you always want the most precise product going into the software process. So let's talk a little bit about understanding the impact of sensor size on processing. And this is, it should be a given. People should understand this. But again, you've got the P5, and then you've got the PAS 880. What one image captures is greatly different. And that can lead to a lot of things. One, in the drone world, we're only allowed to go to 400 feet in the States. So you're confined. That's really all you can work with. In the large format, you've got the ability to fly much higher and capture much larger areas. Like you said, you get the 150, the 280, and the 880. So again, just repeat, if you will, a little bit about the areas that they capture.
All is a matter of productivity and precision, right? But I would set more focus on the productivity, right? If we have your 150 with just one camera, but different lenses, that means you can really change the lenses or be flexible on flying higher and higher. But you're not changing the sensor size, right? This is just one sensor. You're trying to handle the footprint based on the focal length, right? But if you would like to fly higher, what does flying higher mean? Having more footprints, less images, let's say less overlap if you need. If it is classical orthophoto, I don't know, you can fly 60-30 or 60-40 overlap, or if you like to have two orthophotos, the classical 80-80, 80-60, 70-70. So this is somehow a matter of what you would like to achieve. And the larger format means you can fly higher and reduce the costs in the air and reduce the cost in processing. You have less images. You should not be concerned of, oh, now I have a 150 megapixel camera, right? If you compare, let's say, the drone P5, it is 2 times larger than any other existing camera in the market. Sometimes it comes to the table, oh, what should we do with this larger format? Our image sizes are largest, that would be increase in data volume. This is a concern, it is understood, but we have a solution for that. We have a solution with SimActive. That means we can use the image with IIQ format.
It's a reality for some people that they may start off small in the drone world. They get successful, and the next step is going to someone who has another sensor that can acquire data for them, because the reality is a lot of times you can fly stuff with a drone. I did a project once that took 10 days, covered about 10 square miles with a drone because somebody wanted to use that drone. The next year I hired somebody to fly it. I think it was with a 150, and instead of 12,000 images, it was about 90. And you can imagine 12,000 images does not process as fast as 90 images. So sometimes you have to say, I may have the tools and the ability, but I don't have the right tool for this job. I can go, just like I go out and I contract a surveyor to set ground control, I can go and find somebody to fly for me if you have the knowledge, if you have the photogrammetry background, and you have the software to process that data. Why not move up? And then maybe you get, successful enough and you have enough work that you say, okay, maybe now I need to get involved in this. Maybe I need to buy a larger format sensor to do that type of work. So you're right. The reality is the larger the format sensor, the higher you can fly, which means you can cover more ground with fewer images. So that's a big deal to people. And that also means, honestly, better geometry, because when you're that high up and you understand your camera's calibrated, your lens is understood, it takes the software a lot less time to find tie points from high up than it does from really low to the ground. It's a fact. And there are a lot less tie points being made to cover that same large area. So something people should certainly consider on the software side. So one thing that you mentioned, and we really need to talk about, what to me sets you guys apart from everybody else again is the IIQ format. Because typically when you have a really, really large project, you have to go out and find, okay, do I have the storage to handle it? Do I have the backup space for it? Do I have the processing power and all that stuff? That kind of goes away with the IIQ format. So again, explain again a little bit about it.
Yes. IIQ is, as I mentioned, is abbreviation of Intelligent Image Quality. So intelligence is somehow covering the bringing user experience, right? This is UX part of the workflow, right? Not necessarily UI, but UX, user experience. That I feel, well, I am not concerned about anything on the data storage, etc. We had a project with a customer, and we wanted to have the TIFFs from them, and we asked them, "Hey, can you provide us, together with the IIQs, the TIFFs?" They said, "Hey, Mohsen, we deleted them." I said, "Oh, why?" He mentioned, "Because they were too large. We want to save our storage. It is 7 times larger than the IIQ, and we have already IIQs. Anytime we want to convert it, we can convert it, but we don't need it, right?"
Okay.
And I said, "Oh, that was a really good speech and great that you're talking about. Actually, I wanted to tell that to you, but you're telling to me. You're saving time and storage on processing that and going to the next levels, right? You should process it. You should calculate the pyramid levels. There's so many steps coming to conversion, and if you just put these steps aside, you will have more enjoyable lifetime during your production. You are more relaxed on, okay, how is a conversion or everything set, right? It's a feeling. Production, and next day you will come, okay, I've done this job, the next is coming, being more productive, being more passionate to doing more and more and more, right? And the quality part of this IIQ is more important for us. That means the image content, the pixel values, everything is captured and is in a safe place, right? We are talking about overexposure and underexposure. We are talking about bright areas and dark areas. We are talking about, let's say, hot spots and sunny roofs, let's say, and the shadows areas. There are objects covered in the shadowed area. They should come out, right? In photogrammetry, we would like to see more from the scene, right? Maybe if it is in art, we would like to have shadows as a part of this. But in photogrammetry, you want to see everything in the scene. And we would like to see everything which is in underexposure, in dark areas, shadowed areas, and some of them are in the overexposure, in much, much brighter area. And this is a range that we would like to bring it to the homogeneous range, that your scene is very clean and clear and sharp, and everything is fine to extract features. And this is the dynamic range, the difference between darkest values and the brightest values. And we keep it in the IIQ format.
So, I mean, to the layman, it's really a way to keep the raw information in your data set so that, and compress it, but keep that so that, like you said, as photogrammetrists, we certainly want to be able to see shadows because, for example, we can measure base of poles from shadows. You can follow it, and that's the base of the pole. But we also want to be able to see in those shadows. If there's a car in there and the car happens to be white and there's a shadow, you may not see it. So you have the ability to tweak the imagery to suit that specific need without blowing it all up into a full-size TIFF. Yes. Correct? Yep.
The next image or the slide is showing the dark areas.
Yep.
Right. It's actually an area which is somehow captured with P5. And you see on the roof, it is bright, right? You have the brightness and higher values, and in the darkness, it's close to black.
Yep.
really you're not seeing anything. And in the lower part of this slide, you see everything is out of the shadow. So many things are captured here. And if you fly over, cities like New York City with high buildings, the shadow and the sun are playing an important role to bringing objects outside of your scene. And we would like to see the cars, the streets, everything in the shadows, and we bring this dynamic range together. Overexposure and underexposure, that your scene is homogeneous.
That's great. And I'll say that I think it was about 2 years ago that we introduced IIQ into Correlator 3D. So now when you work with phase one cameras, you can bring the IIQ data directly in. You don't have to blow it up into TIFF so that you can process. You can maintain that IIQ format, which is, again, when you're dealing with large data sets, man, it makes a big difference. It makes a big difference. And honestly, it doesn't change anything on the processing time on our end. So that's great as well. We really like that.
Maybe, Eric, something that I really like also from the SimActive. I assume you were the first or the very first software that integrated IIQ, and I'm super happy that you're making the life easy for the customers, right?
I will say we were the first to do it right.
Yes, but I'm getting that from the customer feedback, right? Simplicity on SimActive. Life is easy, right? The photogrammetry life gets easy, and is very important. It's not only a matter of precision, which is the most important, but also productivity and happy. And the interesting thing that I like really in SimActive, that if you are utilizing the 280, which has two of these cameras with 90 millimeter, you are doing also in your integrated solution the stitching.
Yep.
This is very unique.
Yeah. So, and we're talking about simplifying your processing workflow when we talk about the IIQs. The other thing that we had talked about a little bit earlier is calibrated cameras. So you guys provide to your users a calibration report, which they then have, so that when they bring that data into Correlator 3D, they don't have to necessarily let the software do the calibration. If there's a calibration report already available, you can feed that information, and I'll show that in the demo. You can feed that information into Correlator 3D. When you do it once, it's there for good, so you don't have to do it again. And you could just import a text file. It's not hard to do. It becomes really important when you're working with 2 cameras or 4 cameras, because you really need to know where they are in space and how they relate to each other. As you mentioned, with the 280. And also, we want to maintain the IIQ value for each of those cameras and be able to stitch them together. So that's a challenge. But if you have a calibration report, which we do, then it goes in real easy, and I'll show that. So the other thing I would mention is that when Correlator 3D will work with more than one camera. It'll work with 5 drones flying cameras. It'll work with 1 large format aircraft flying a camera with 4 sensors in it. But how you set that up becomes very important, and we will also show that in the demo. And it really comes down to entering your camera parameters properly. And what's good, phase 1 provides you all those parameters. So it's again, easy to do. And then the last thing that we always mention to people, that when we go into simplifying your life, is applying a geoid value if you need to. That is not something that comes from the phase 1 cameras, but it is tied to an Aplanix sensor. And if that a Planet or whatever, it could be Novatel. But when it's tied to it and it's capturing information from satellites, that is that doesn't necessarily there it is. it doesn't necessarily involve the geoid when it's being post-processed. If you forget to do that when you're post-processing in correlated 3D, you can just select the geoid and it will make that correction to all the imagery without actually changing any of it. It'll just make that correction so that you can continue to process your data. So those are some things. And again, I see you've got a Trimble pointing out there, so you might want to mention that to everybody.
Yes, actually, not specifically on the sensor. I'm talking about, as you mentioned already, right? There are applications they would like to have just direct georeferencing, right? They are satisfied with the whole procedure without GCPs, right? Maybe some people would be very sensitive on using the GCPs. It's very important, but in some applications they use the direct georeferencing, right? With either it is Trimble or Applanix and RTX technology, etc. They fly with 150 or 280 over an area forestry where maybe sometimes you cannot collect the GCPs in that area, or sometimes it is not possible, or sometimes it's not needed, right? Exactly, coming back to the first question, what is your demand and what is the specification?
And you're absolutely right. For a lot of forestry applications, you can't get out there to put control on the ground. A lot of stuff that the military does, you can't get out there to put control on the ground. So direct georeferencing is your solution, and it does work in those applications. So you're absolutely right about that. So we've kind of covered everything. I will get into the demo that Don and Parker shared with us. But before I do that, any final comments from you from phase one?
No, thank you. Thank you very much. I would like to thank very much Air Data Solution, to the team from Don. They're super productive, super busy, and what I like from them is they are super creative, right?
Yes.
They utilize the prepared systems from phase one, let's say 150 or 280, any of these past systems. But they are super creative in making their own system based on the component cameras that they have, right? And I like it a lot. It's always a joy if I exchange with you and the team Air Data Solution to know more. What are they doing? What's the applications? What's the demand? What's the requirements? What's the sensor they're using? How they combine it with other sensor? It's super interesting. Thank you, ADS team.
I really like that the people that are using the phase one systems are also, I don't know, they're also creative and trying to do new things with them, make little changes, this and that, which I'm sure all that feedback comes back to you guys. But this is really, on the large format size, is the only place I hear of that happening. So that's a testament to, the solidity and the flexibility of the systems that you guys provide.
Great, thank you. I appreciate it, Eric.
Absolutely. Well, I appreciate your time. I hope to speak to you soon. Okay, on to the demo where we will cover some of the things that Mohsen and I were discussing earlier. So let's go ahead and set up the project. We'll use the medium format camera. We have two cameras in one group. We have a left camera, the master, and a right camera. We'll go ahead and go through the normal process. We add our folders. So we go to images. We have left, and we can load those. One point, make sure you set the geoid here. So we're going to set the geoid. And we'll go ahead and we'll pull the EOs. Right there, we have left phase one, and you can see it's pulled in all the EO information and it's left the geoid where it's supposed to be. Now our projection is 32614, and we're going to go ahead and continue. So now we want to import the camera calibration information, and there it is for the left. And we've imported that. And we'll go about adding the next set of images. So now we're going to add the right. We'll go through the same process. Make sure that the geoid is set. Add the EOs. And then move on to the projection, which is already auto-filled. And then work on the camera calibration. Again, we also have a calibration for the right camera. We'll go ahead and load that. And all that information's there. And then we'll continue with the project. Now, I have processed this already, so we can jump some steps here in a bit. Create the folder, fix the R, and we can finish. So now we can see all of the images in the right area, and you can see we've got some water to deal with too, and we'll go ahead and begin the bundle adjustment. As I said, I've done it before, so we've got this data in hand. Let me switch over and I will show you the results of the bundle adjustment, and we can take a look at those. And now we can move on to the DEM processing. All right, so let's look at the DTMs that were created. Again, I've created those, so I've jumped forward. We have the original DSM, which you see here. Now we do have water in the scene, so we've got some editing to do here, but I've already created those. So the next thing, of course, is you would create a DTM. And from there, you could go into the DTM editing tools, which are right here. For example, I'm not going to run it, but I'll show you. You can then select the entire area. Okay. And we know that we're at the ocean, so sea level being 0. You could do something like this. You could do a snap to everything below 0. Let that run. And now it's giving you everything that is below 0. And from there, you could then go in and raise the elevation, say set the elevation to 0, and it would raise all that to 0. What we do now have is, I'll go ahead and get out of this, is we have that final edited DTM, and you can see it right here. So now we can go ahead and make our orthos, which we did. And they are right here. And you can see the orthos here. Now be aware, we did this in 8-bit rather than 16-bit for the demo, but of course you can process out 16-bit. So that's certainly there for you if you want to do that. And again, that's just in the ortho creation. When you go into here, you have the option of 16-bit or 8-bit. So those are your choices. For the demo, we didn't need to do that. And then we can look finally at the mosaic. And here we have the mosaic. We can turn off the extra images, and we can zoom about the mosaic to see how everything came out. So everything looks nice, and we can pan around. And again, this is a big oil and gas site that the client ADS has used the phase 1 280 camera to process the data. So this actually turned out being, let's see, on the images side, I believe there were 190 images. So 190 images, and the area was a little below 9 square kilometers. So you can see that, you know, a larger format camera will capture a larger area with fewer images. Fewer images processes much faster than lots of images. So as a operator or as a company who is working, you can look at that and say, can I do this with a drone? Should I be doing this with an aircraft? Of course, there's a value to one way versus the other. There are limitations, again, with altitude for drones. So you have to be aware of that. But you've got options. And what we like to say, again, when we see anything that comes in with a phase one camera, whether it's a P5 or, their 280s, you're going to get good data, and you're going to have a lot of great options. Like Mohsen said, you have basically got raw imagery that you can adjust throughout the process. And that raw imagery is compressed. So you're working with much smaller files than you would be with TIFFs. Now, not all software can bring in IIQ imagery, and not all software can handle larger format cameras or larger data sets. So be aware of that when you look to pair your processing software with such cameras as a phase one. So I believe we've covered all the topics in the webinar. I know that there are some questions. Please be patient with us. We're trying to get through the webinar. We will answer your questions as soon as possible. With that, I'd like to thank my guest, Mohsen. Thank you. I'd also like to thank you for attending. This webinar will be turned into a podcast in the near future. You can find this webinar and all of our other training materials, including previous webinars and podcasts, on our website, simactive.com, under the Learning tab. Until next time, thank you for joining us.